Exam 2 review. Let's do this. So I will review what I feel is important, and then from time to time I will stop and check the chat for questions. So you guys don't be afraid to post in the chat, whatever you want. And then I'll see. So it starts with improper integrals. Do you guys remember that? Like improper integrals were a long time ago, but they always go to the second exam because it's something about limits and accumulation, and then we go after that. So improper integrals, like so. Improper integrals will be either multiple choice of response. We actually choose from time to time between this and that. Students usually do really well on these. Your job is to remember not to be afraid if you see infinity or something else which looks weird, dx. That is weird to have infinity or division by 0, for example, and that's where limit comes to help. You write down the limit. Imagine that this is normal different integral from a to b to e to the minus x dx. Yeah, the stylus is weird. And then x, and then b, or whatever you call this variable, which is annoying, goes to infinity. Limit will be used only at the end. In our classes, I always keep writing it with a limit, but actually you can just solve separately this different integral. And then remember that b, which is in blue, explodes to infinity. So I'll keep writing limit. If you don't write limit, you're actually doing a mistake between this equal sign. Don't put this equal sign if you don't write the limit, because limit actually is the one that allows you to put an equal sign. Use substitution or shortcut allows you to solve these integrals fast. This is my shortcut from 0 to b. Post in chat if you want me to review this or any other shortcuts, and I will do it right now if you need. Still limit, we cannot use limit until we plug b. So it's going to be what? Minus 2 e to the minus b minus 2 e to the 0 or minus 0. Always put parentheses here. That will help you not to screw up the answer. It's actually a very good habit. It will save you lots of lost points in general in the future in the math classes. This negative sign will change the sign of the second term. E to the 0 is not 0. Many people make this mistake for some reason. So just reminding you about that. Do I need to admit someone from the waiting room? Okay, yes. Now it looks good. So this term is actually minus 2 times 1, so just negative 2. Now everything depends on b. Here's b. I forgot to ask if you see what I'm writing, but I think I see what I'm writing, so I think you can see it.
Yeah, we can see it.
Thank you. So now you remember that b actually goes to infinity. And now it's important to which infinity it's going and how does it go and stuff like that. So everything now depends on your knowledge of what is happening with e at minus infinity. So again, if b goes to minus infinity, it'll be minus, which is plus. In this case, b goes to plus infinity, so it's just minus infinity. And now this is where you stuck. And then there's so many ways to see this. Number one, numerical way. It's e to the minus b, where b is approximately some huge numbers. The bigger, the better. Take your calculator, plug it in, and see, is this number big or this number small? That's kind of the idea between these ideas, between these questions. That's called a number sense. So when we're sensing how big the number sense. Second way is to graph it. You can also use a graphing calculator. What is the graph of y equals e to the x? And you're like, oh yeah, remember, it looks like this. So where does it go to plus infinity? At plus infinity, it goes to plus infinity. But at minus infinity means x goes to the very, very left. F of x, which is height of the graph, shrinks to 0. And that is what you're going to have when you plug huge numbers into b. Then you will see that e to the minus huge numbers is a small answer. And the third way, actually there are more than 3 ways, but e to the minus b can be written as 1 over e to the b. b still goes to plus infinity, right? But now this is a huge number that explodes in the denominator. If everything explodes in the denominator, the total shrinks to 0, calculus 1, if you remember. So this way also is working also. So the answer is 0, which is good because this whole term, the whole term is 0. If the whole term is 0, not infinity, then the final answer will be some number. 0 minus 2, which is 2. The answer is 2. And the answer says converges, this interval converges to what? 2? Not 0. To 2. That is the answer. Yeah, that's how I would do it. Keep going with more stuff. So people are asking to explain the Laplace transform problem. That is number 3. Did I put it on a test? Let me just check.
It was on the practice test, but I don't remember learning it in class.
Yeah, I review. I see it in front of me. The Laplace transform we teach in differential equations class, but it is a subtopic of improper integrals. That's why sometimes they like to put it as example. They like to say, oh, you don't know this name, but actually you're already good enough to work on it. So they say that Laplace transform, capital L, that is capital L. And then they use this. The function is the input, which is new for us, but actually it's indefinite integral from 0 to infinity e to the minus st times this function f dt. This looks complicated until you plug the function and they tell you, hey, find capital alpha at 1. That means f is 1. That makes a complicated integral to be very simple, indefinite integral e to the minus st times 1 dt. Almost the same what I just had, but the only difference is that s is not given, but they say that s is a finite number. In the previous example, s was given. It was -1 over here. That's what we had in the previous example. So this function is very popular. That's why they decided to kind of introduce it in the practice exam. Practice exam was created like 5 years ago. So this review, they decided to say this is actually a very common function, e to the minus something something. And now everything depends on s. What does this s do? If it's a finite number, it converges, because the last example showed us this. It converges to what? And you can solve that. Yeah, I don't put it on the test. People freak out. The first year we did it, people did not do well because they freak out over the notation. And I like, that's not fair. I mentioned it. I think it's not fair. People just freak out because something unusual. They're not really checking the improper integrals here. So it's a cool thing to like review. I mean, let me just make my point. It's pretty cool. But I personally don't put it on the test. But it is improper integral. It's a nice, cool example of improper integrals. And yeah, engineers actually use it quite a lot in their studies. We were discussing it yesterday with my colleague who is using Laplace transforms, and this answer for that is engineers. So that's for engineering majors, should be interesting to know. One more, let's do this one. Kind of people stuck usually with this one. dx. How come the answer of this integral is pi over 6? Because this is improper integral. We can write it down as a limit from a to 0, where a is going to very, very small, very, very huge negative numbers. dx over 9 plus x squared, like so. But what is the integral of 1 over 9 plus x squared? It's some kind of arctangent. So what kind of arctangent we learned in the previous exam? And you write down, this one isn't going to fit. Limit a goes to minus infinity, arctangent. And then you have to figure out the arctangent works when this number is 1, but it is 9. So to figure it out, you factor out 9 and put it inside as 3 squared, blah, blah, blah. That goes from the previous exam. Kind of, I just remember the formula, to be honest. that when you have the number over here, you will divide by the square root of this number, like so. So it will be arc, change the color, it will be tangent -1, and then x over 3, the square root of 9. A bar from a to 0. Limit a goes to -infinity. Then it will be arctangent of 0 minus arctangent of a over 3. And now again, everything depends on this tangent of a over 3. What does it do? Arctangent of 0 also checks if you understand what inverse trigonometric functions are. Arctangent of 0 answers the question of tangent of what angle gives you 0. Well, actually infinitely many, but on the restricted domain from -pi/2 to pi/2, the answer is 0.
Shouldn't the arctan be like arctan over 3 times x over 3?
Oh, I lost 1/3. Yeah, thank you. Good point. When you factor out this 9, this third over here, and also you factor out 1/9, but then your substitution shows up. And after all, I usually factor it out outside. You have 1/3 in front of it, like so. Yeah, thank you. That's what I wanted to explain. 1/3 over here, right in front of everything. Then this term is 0, and everything depends on arctangent of -infinity divided by 3, which is -infinity. This, again, you can do number sense. Just plug some very huge negative numbers into, so let me write down. What is arctangent of like -10,000 over 3? And check what does it look like? Probably you'll get confused because your calculator will give you some number looking like 1.777. But the graphical way is the best one. I would do the graphical way.
Can't you just like look at where tan goes to infinity?
Exactly.
Or
that's what I would do. Good job. The tangent looks like this. It's a chair, just like cubic function, but this chair has a specific properties that it stuck between two walls. It's not an infinite chair. And it has two symmetrical walls from -pi/2 and +pi/2. If you think this is complicated, very good, because it took me years to actually learn all the graphs of trigonometric functions. So definitely don't be worried about that. It comes with practice. So there's two walls, and then it asks you the question, at what point you get -infinity over 3, which is -infinity basically. And the answer is here. The tangent is looking down at -pi/3. Right? Oh, my place, -pi/2. Just said something weird. So the second part will be -pi/2. Minus gives you plus. So it becomes pi/2, but there's 1/3 multiplied in front, third to pi/6, like so. That is the idea. Pretty cool. So it checks your knowledge about that. Yes, Sarah was right. It is 1/3. Tangent x over 3, thank you. The square root of 9. So, and then check other cases like number 5 and so on. Those are infinity cases. So I like putting infinity cases on the tests. So infinity cases also. Integral dx 9 minus 2x. That is a logarithm. What does logarithm do? At -infinity and 0, you should check this out. This is on the review. But they're not only infinity cases. Some cases look very normal, like so. Like number 9 on the review. From 2 to 3 looks very normal. Integral 21 dx over a square root 3 minus x. But now we know that we cannot divide by 0, but this 0 point is included. So my notation, I put it in a circle, making it look like it's a dangerous point. And it is, because we divide by 0 at this point, and we should not. So it's going to be integral from 2 to b. B goes to 3, 21 dx all over the square root 3 minus x. Integrate the integral separately. In this case, it is a power rule, actually. or you can do your substitution, figure it by yourself, plug the top minus the bottom, and check out what's happening at B when B goes to 3 in this case. In this case, 3 can be approached only from one side. The sketch looks like this. We are working on the interval from 2 to 3. So how do we approach 3 then? From the left only, and that's why this negative sign shows up. It will not change the calculations, but it's just correct to write it down. And that's all you need to know about improper integrals. Your job is to remember how to integrate and then use limits, whatever you learn about limits from before. Let's move on to areas. Areas between graphs. And now it's a very natural list of topics. We do area between graphs. Right? Or curves, graphs, both are correct. Then from that, we start rotating that area. And that takes us to the disk method. Then when we rotate, we sometimes can see gaps. That takes us to washer method. And then we decide to introduce shell method as unfolding idea. And then we're done with that. That took us to the problems of work, because apparently when the pool is being created, it has connection with the disk washer methods as well, because it's like infinitesimal numbers of volumes of water or any liquid. Infinitesimal means infinitely many small pieces accumulated together, and we are lifting them up. That is the work problem. Same with the rope lifting up. And then we switch to chapter 8, and we're going to keep going with chapter 8 next week. Actually, next week on Thursday already. And that one was sequences in series. And the only thing I did not mention was what arc lengths. What is the length of the rope? Which is also a natural question, why we never figure out how to figure out the length of the rope. And then we learned that it also has a formula with the integral. So let's do that, very natural sequence of topics. Idea is, let's do number 1. Honestly, this is the best part to put in a test. Usually the students do really well. Your job is to just practice this. Area bounded by, BDD bounded by. And now you have stuff. Sometimes I will give you the graph, sometimes I will not give you the graph. That was required by the engineering department to make sure you guys know how to sketch graphs. So kind of sucks, but definitely forces you to practice a lot. I promise I give you something very trivial. For example, this one, this comes to be trivial. I hope that's the case. You know, I'm always scared to say that. This is the system. Area is bounded by these 2 curves. Do you imagine it right now in front of you in your imagination, how this looks like? Again, don't think that I'm just very smart and that's why I can draw it so fast. It takes lots of practice. But I kind of remember that y equals x is the line that cuts everything exactly at 45 degrees. But we have y equals 2x. So it's also a line just a little bit higher because it grows faster, right? For every input, output will be twice higher. This is some kind of line, doesn't matter. And then this thing is a parabola. Y equals ax squared plus bx plus c. We told you in pre-calculus class that will be important. So yeah, it's kind of everywhere. And you remember, if a is negative, then parabola is sad, which is concave down. I even teach this right now in my business calculus class. Second derivative is negative, then the graph of the function is grumpy, see, because it's sad. And the nose of that grumpy function is the maximum. And then if a is positive, second derivative is positive, we see function is happy. And the tongue of this happy function is your minimum. So that's how I teach in my calculus 1 classes. Usually engineering students, they like it. And then business students were not impressed at all. They roll their eyes. They're like, what is this? Anyway, but I think it helps. People tell me that it helps to remember because it's funny. And sense of humor helps to remember formulas pretty well. There's a whole study about that. So there's some kind of parabola looking down and it's shifted here and there. I don't know. I know it's not at zero. It is zero, but that's not the vertex. If you want to know the vertex has a formula minus b over 2a. That is a vertex. And all of this is needed if you don't have a graphing calculator, but you do. So when I was taking this class, we were not allowed to have graphing calculator. You guys do, so that's actually kind of very cheating. We always complain. Europeans complain about that here you're allowed to have graphing calculator. Looks something like that. So your job is to figure out what is the area enclosed or bounded by. Here it is, has points 1 and 2. Now, your job is to figure out which case to use, right? Let's see if I need to admit anyone. Everything was good. Which case to use. So step 1, sketch the picture. Step 2, choose the case. And we have 2 cases, top minus the bottom. That's case 1, when one function is always at the top and the other function is always at the bottom. And that's what I can see here. I can see that the green function is always at the top, while the black or whatever this purple color is always at the bottom. So you can see the scanning will look like this from top to bottom. That is case 1, top minus bottom. This will involve the integral from a to b dx. That is how you should remember it. And then it will be top minus the bottom inside, like so. If you have case 2, then the scanning will be from right to left, And you always remember bigger minus smaller. So right is bigger than the left and top is bigger than the bottom. So that's always the same idea actually. From C to D, right minus left, dy. So each function now has to be x equals f of y. That's the kind of the problem of this second case. And the first case is y equals f of x, which we get used to. Choose the case. Actually, this problem can be solved using 2 cases, but one is easier than another one because y equals gives you the hint. So let's choose the first case. When you choose the first case, make sure you have functions written as y equals, then finds points of intersections. Points of intersections, like so. That means solving the system. Y equals 5x minus x squared. Y equals 2x. Maybe move everything to the left-hand side. Minus x squared plus 3x equals to 0. Solve quadratic equation. In this case, it's factoring. X minus x plus 3 equals to 0. X is 0. X is 3. And you should see it graphically, should make sense. You shouldn't get minus 12 and minus 1, okay? Or like minus 25 and 7. Graphically, it should look nicely. So I got 0, and then I got 3, and it kind of makes sense from my graph. So I like, yeah, visually it makes sense. So that's actually your hint to check the points. And now you have to build the integral. Step 4. Extra step for the different case. If you need to solve for the different variable, you need to do that. In this case, it's integral from 0 to 3. Top function is the one in green. That is parabola that making shade on top of the line. The bottom function is the line, which is y equals 2x dx. Simplify, integrate, plug the top minus the bottom. The answer better be positive. If you got a negative answer, you messed up. Either check the order, left minus right, check the points of intersection, it's from 0 to 3, or maybe you just completely something different, you know. Let me see, what are functions I even put on the test? It's kind of curious. Totally don't remember. I was so responsible doing it before the spring break, but now I don't remember. What is that? Let me see. Yeah, very classical one. Lines and parabolas. Lines and parabolas. Should I review sine and cos? Okay, let's review how sine and cosine look like. Again, you have graphing calculator. That's why I think it's fine to put it there. That's just in case. Yes, let's do that. Number 2. That's kind of weird. Let's put it that this was number 10. This was number 10, and then it's 11. Example number 11. And this one is coming from here. Sine and cosine, like so. It's actually not too bad. So number 13 is good. Okay, good. Let's do number 13. That is number 13 on the review. So there's a practice exam there. Definitely check that because it's really good. It took me hours to create it, but then students told me it was really helpful. Because I asked them later, did you even do it? Do you need to keep creating them? And everyone said yes. I had to keep creating others. Students asked a lot, and then they told them that it was really helpful. But I told you, when you go to Gradescope, for every single problem, I put the link and saying, this is a screenshot of the problem from the practice exam or from the review. So that's why I always feel fair. Even if the problem was weird, it was on the review. Although I tried to avoid putting weird problems in the test. Bounded by those two functions. So you use your graphing calculator if you don't remember how to plot things. But to be honest, you just need to remember how cosine and sine looks like. They a little bit maybe shifted or shrinked, it doesn't really matter. Y equals sine x starts from 0 and then wiggles forever. Y equals cosine x starts from 1. They both go from -1 to 1. And then wiggles forever. So that's the difference. And then cosine is 0 at pi/2. Y sine is 1 at pi/2. And then 0 at pi. So that is the difference. Basically, cosine is a shift of sine, and sine is a shift of cosine. 0, that's 0, makes sense. And then pi/2, like so. So in this case, that gives you immediately the sketch how in the world this can create the area. The area will be like so. Okay, cosine starts from 1 and then creates this bell, right? Like so. And then 12x squared, 12 is positive. So now this is parabola looking up. It's a smiling parabola. Has a vertex somewhere at 0, 0. Let's check. X minus b over 2a gives you b is 0. There's no b here. So the vertex is somewhere has x equals 0. So it's somewhere here, but it's shifted by 3 units down. See, that's your transformations of graphs chapter in calculus, pre-calculus class, calculus 1 or pre-calculus 1. Anyway, it's a bell, it's a happy function looking like this, it's smiling. And then we only need one thing, one type over here. So that is the area enclosed from. You need to find points of intersection. That's kind of the weird case here, but we don't get there yet. This was the first step. Sketch the graph and then maybe sign everything, but kind of I remember that the first one was something about cosine and the smiling one was something about parabola. So, but it's actually nice to sign everything. And I'm like, yeah, I don't want to do the right minus left, obvious. That will be definitely case 1, and I cannot do case 2 here actually. I can if I break it to pieces. No, it's only top minus the bottom. So step 2, we choose the case 1. Then it will be step 3, integral from to. Well, we need to find the limits of integration. And that's why you solve 8 cosine pi x equals 12x squared minus 3. We're literally asking when this is happening. That is not trivial at all. That's why this example is a little bit overkill. Basically, there are infinitely many solutions, to be honest. but only for this part of the graph. We only need 2, -1/2 and 1/2. There's a step away to the left by 1/2 and step away to the right by 1/2. So you check solutions, how we're solving it, because that's not very interesting to do before the test. Check the solutions in the page number 5. And then it will be integral from -1/2 to 1/2, top minus the bottom. So the function cosine goes first. Parabola, don't forget this parenthesis will be very important. Goes next. And then dx case, you solve it and you better get a positive answer. Or for the multiple choice, you just choose the integral from the list. Check more cases in my review and practice exam because they're all good. Definitely practice case 2. We definitely put both cases on the test, case 1 and case 2, just to make sure you understand both. Questions before I move on to the disc and washer? And let's move on. Very naturally after this, we start doing volumes because apparently when you rotate flat things, they create 3D things and 3D things have volumes. Area is a property in 2D while volume is a property in 3D. So the orange, for example, can be created from rotating a circle around its own axis, right? Axis of rotation, and it creates a sphere. How to find the volume of the sphere? Well, actually we know the formula, but now we also know several methods. Either you peel it shell by shell as a shell method, or we're slicing it, creating lots of slices of orange, pile them together on top of each other, and find the area now of each slice. But slice has width, so technically speaking, it's volume. It will be easy. Area multiplied by the height of the slice, which we're going to fix to be very small, infinitely small, which creates the integral by the definition. Let's do that. Let me check just a second. I'm kind of curious. What did I even put it? I usually put very classical functions for these problems. So just kind of checking that you know how to do it. Shell method. Yeah, very classical stuff. Sometimes just building the integral is good enough. And then methods of disk sort. So I even tell you which methods to use. I think, let me check this one. Calculate the volume obtained. Except for the free response. For the free response, you have to make a choice by yourself. But for the multiple choice, we usually tell you use disk or washer or use shell method. Yeah, very classical, actually, all the examples. That's good. Let's do it. So we first learned that we can slice the 3D object, for example, this vase. This is a 3D object of vase. And we can slice it with a vertical or horizontal, that's the x versus dy case. Disks. Disks means it is filled in. Disks, solid, not hollow. Each disk will have a very, very tiny width, which we're going to call dx or dy. Depends where the shadow of that thing goes. So for this case, actually, it is the shadow goes to the dy axis, then it will be dy. If that is horizontal slicing. Vertical slicing will be dx. Anyway, area of the disk is known as pi r squared. And then we're multiplying by dx from A to B. And some infinitely many dx's. Infinitely many dx's gives you this integral because integral is the Riemann sum. Infinite sum of the area of the circle multiplied by the width of the circle. A circular disk. Disk doesn't have holes inside. That is the thing. So let's practice that. Let's do something reasonable. Let's do case 2 since we don't do case 2 yet. dy case.
Sometime in here, will you let us know? I remember you telling us about some like rule of thumb on whether we should use disk or the shell method. I can't remember what it was. If you could just like touch on that, that would be
Yeah,
great.
yeah.
One.
Yeah,
Okay,
yeah,
thank you.
definitely. So this is how I will tell. That's a good idea. Let's not break into topics then, because as you can see, we don't really tell you which one to use. Good point. See, very good point. This was a disk idea. When you see that the object was created from the rotation, so it's the same base, but now it is hollow, and being hollow means the original area either stepped away before the rotation happened, like so, or it just had a gap originally. If there is a solid part and there's a hollow part, which means empty part, then this is what we're gonna call a washer. I like calling it a ring because I see what ring means. And washer kind of sounds like a washer machine, but actually they mean a washer from the construction. But I like imagining ring because ring, exactly this disk, which I just had here, right? I had this disk, same thing. I should not make it so thick. It's the same disk I had before, but what is the difference? Now there will be another disk inside with different widths, right? Same widths, but different radius. So now if you think about that, that's a ring that you can put on the finger like so. So the formula will be different then. For the first scenario, you'll have integral from a to b or c to d with dx at the end. Pi r squared dx or pi r squared dy, like so. While the formula for the washer will be the, let's do this. And that also might be not that simple if you have a shift, but the idea that this r is area between curves, and that is why it takes us to the previous chapter so naturally. R is the area between curves, and that might be area minus area, right? While the second formula will have this idea twice. It will be pi r squared minus pi r squared dx or dy, right? From A to B. You first find the volume of the filled in or full 3D object or solid, basically. Let's do solid. And then subtract the empty part of this 3D object or hollow. And that is why you have a bigger radius first, and then subtract the small radius, pi r squared minus pi r squared. If I zoom in, it will look like so. The big radius starts from the axis of rotation and go to the edge, that is r. That is the big one. For the small radius, that's the green, start from the axis of rotation and go to hollow piece when the hollow piece is in, done. Like so. That is a small r. So big R represents everything. Small r represents only the empty part. Subtracting empty from the full gives you the difference of washer. Now we can do examples unless you have questions. So you can post in chat or just unmute yourself. I'm checking both. Let's do that. I like this one. This one's good. Number 23 in the review, but it is number 12. Problem number 12. They say find the volume created by rotation of the area bounded by, right? So just learn how to read it fast. X to the 1/3, x equals 8, y equals 0. And now the new thing happening which is different from the previous chapter, a rotation about what? Y-axis. Okay, what do we remember about this idea? For the first two examples, washer and disk, if you're rotating about y-axis, you expect to have dy integral. Let's put it here somewhere. Volumes. When you work with the washer ring, washer is the ring, with the washer or with a disc, then rotating about x-axis will give you case 1 dx. Rotating about y-axis will give you dy. This naturally falls out from the idea of how we're slicing things. If we're slicing things like so, these all rings or washers are located horizontally. That's horizontal slicing. Then it's going to be dy, but it is rotated about y-axis. In this case, something parallel or parallel to. Same thing, so or parallel to y-axis or parallel to x-axis. This guy was a shift, so it's a rotation about something parallel to y-axis, and that's why we know it's going to be dy. Here it says y-axis, so we already know it's going to be case 2. So all functions have to be written as x equals f of y, and that's going to be extra step 2. But other steps are classical. Step 1, picture. And let's have 3D picture, remember? So do 2D picture and then 3D picture. While for shell methods, I recommend not to do 3D picture. We have the axis, x and y. Functions are, no, this is x equals y cubed. So that is a cubic function. But you need to tilt your head to imagine the chair. Cubic function is a chair, if you remember, it's like so, infinite chair. But this one, you need to tilt your head together. So it will look like a chair, but looking like so instead. Pretty cool. And it's an infinite one, doesn't have asymptotes. Y equals x to the 1/3. But again, use your graphing calculator. The earlier you learn how to use it, the better. X equals 8 is here. That's one of the walls. X equals 8, wall. That's still not restricting the area. So y equals 0. That's x-axis, y equals 0, that's one more wall. And that creates this nice area. Okay, 2D picture is done. This is the area we're looking at. Rotation is happening about y-axis. And because of this gap between this cubic function and y-axis, we will have a hollow 3D object, which means it's not going to be solid. I copy it like so. Adding it some nice 3D shape so my brain can visualize it better, like so. Looks pretty nice. This is my 3D object, and I like this notation I saw in America, that you indicate rotation about y-axis. No, it's not common rotation. Not common notation. Not everyone doing that, for you to know. Choose your case. Step 2. We chose case 2 because it's rotation about y-axis. Done. Step 3, find points of intersection. So when you chose the case, now you can sketch the sign, the shape of the integral. It will be integral from C to D, right? Let's see. Before you do that, choose if it's washer or a disk. That will be better. I can see there's an empty piece over here. So you can imagine if you're pouring water into this object, will it stay or it will fall off? It will accumulate there inside. So that is washer. This is washer case because it's not solid. Let me write down, not solid. Then the shape of the integral will be pi r squared minus pi r squared. Pi r squared minus pi r squared, where capital R, big R is a big radius, small r is a small radius. dy, like so. And I usually factor out pi. So we need C and D. C and D means I need to find how tall my object is on the y-axis. The one is obvious, is 0. The other one is not obvious. We need to actually find it. But the idea is how we're finding it is the same. We need to find this point over here from intersection of those two curves. What two curves? That's why signing is so convenient. Y equals x to the 1/3 and y and x equals to 8. x equals to 8, like so. Plug your 8. Y equals 8 to the 1/3. What is that? That's 2. 2 times 2 times 2. That's the third root, right? So y equals 2 is the height of the object. And the other one comes from the intersection of these two functions, which is y equals 0 and y equals x to the 1/3. And that's why y equals 0 is the other point. Anyway, the integral becomes from 0 to 2. That's the height of the 3D object. And now the most interesting part starts. So let me pause for a second. Let's see. There's so many people still here. Very nice. Good job, people. Look at that. So concentrate. So first, the big radius comes. The big radius, zoom in your picture. That's why it's nice to have a big picture. You know, I'll give you sketch paper, so just use whatever you need. The big picture is, I mean, like a blue color. Go to the axis of rotation. Shoot the laser, if you want to see it this way, to the edge of the 3D object. So ignore the gap. There is no gap. It's just all filled in. It's like you're filling it with, say, glue, and now it's all solid. That's it. What is the area of this part? We are doing dy case. Dy case is right minus left. So every time you're using this formula, which I created here, pi r squared over here, or pi r squared minus pi r squared, r will be area between graphs. I already said it, but let's review it again. So it's going to be either top minus the bottom for the x case, or right minus left for the y case, like so. So that's what I'm doing right now. Very important, very important. What function is on the right? I'm looking in here and I see the wall. That is a wall called x equals 8. Make sure everything is written in the form x equals f of y. Luckily, x equals 8 exactly is what I need. X equals 8 is on the right. Right, minus. What function is on the left? The function is on the left is this in black. No, that's actually is important what is happening right now. What function is on the left? We're starting from axis of rotation. What is the name of this function? That is x equals to 0. Yeah, that is what I wanted to say. X equals to 0. So the other one will be blue. X equals 0. And that is that is left, squared pi. I will factor out pi outside because have pi r squared minus pi r squared can be factored out. But this is my capital R squared. Does this make sense? So in my solution, actually, I don't say that explicitly because I did not know yet that year when I was writing this, which took me like 8 hours, I think, to write this key. The students will get confused about this part so much. So now I'm explaining this carefully. Every radius is area right minus left or top minus the bottom. The big radius, you ignore the gap. There is my R, like so in blue. Now I will do minus pi r squared, and the second r is small r. The small r only should be found with the gap. Shoot starting from the axis of rotation and stop when it hits the wall. So you only need the empty part. What is the area of this piece? Right
The
minus
actual
left.
function.
Huh?
Sorry, I actually thought you were asking. My bad. I didn't know it was rhetorical.
Oh no. Oh yeah, that is your definition. Good job. What is the function on the right? What do you think? So this is actually a tricky function, tricky question. So we're gonna have, again, let me write down slow. Small r squared over here And again, we're going to have right minus left, right minus left. I see the black function, which I just made green, but whatever. This black, now it's blue. The black function or green function is on the right. This function is y equals x to the 1/3. X to the 1/3. Does this look correct to you? And this is how you catch mistakes. Why the x show up inside of the integral, which will be dy. And that's why I like writing dy right away. It will remind me that nothing inside should have x's. That will be taught in Calculus 3 class, but not in this class yet. So I cannot write down y equals x to the 1/3 inside. And this is where it's a good step doing it here. Sometimes people teach you to do it right away, which is also nice. But actually, you can catch this mistake when you write the integral. You just like, oh yeah, that doesn't make sense. Y equals to the x 1/3 should be rewritten as x equals y cubed. So I am fixing this and writing it down as y cubed x equals y cubed. What is the function on the left? Luckily, 0 again. What happened? Good job. Axis of rotation. So the empty part is this part in white. See, all this part in white is your empty piece. So what is the function on the left? X equals 0. X equals 0. Finally, this integral looks like this. Integral pi is factored out from 0 to 2. And I have 8, don't forget 8 minus 0 is 8, but it's also squared. Minus y cubed minus 0 is y cubed, but it's also squared, because remember, pi r squared minus pi r squared. And now you integrate that, which can be done fast. So pi from 0, oh, I don't need to do it. 64 y minus y to the 6 becomes y to the 7 over 7. A bar from 0 to 2. 0 makes everything 0, so just plug 2. And you will have 768 over 7 pi. Never plug pi as a number. Pi is pi, don't touch pi. On Monday, there was a pi day, by the way, so happy pi day. Okay, belated. What do you think about that? That is a disk versus virtual method. I can do disk method maybe a bit later, because I want to, I can do now to do 1dx case to compare, or I should do a shift. Let's do a shift, actually. That is even better. Let's do a shift case. Why shift is so annoying? Let's see why. And why you are getting so slow. Yeah, fine. 12, number 13, problem number 13, but it is number 20. Bounded by y equals x squared, x equals 0, y equals 4, about y equals 4. This is when you know it's a shift. It's not x-axis and not y-axis. That's a shift. The thing is, you immediately realize that this is a shift. But which one? X-axis shift or y-axis shift? Well, y equals 4 is parallel to, and are you imagining? Y equals 4 is the horizontal line. It's a height 4. It's like floor 4. So it's parallel to x-axis. And in general, it's just always the opposite. Y variable to the x variable, like so. So it's parallel to x-axis. If it's parallel to the x-axis and it is going to be disk or washer, it's going to be dx case, unless it's shell. Shell is the opposite one. Shell will do dy case. Step 1, sketch the picture. Y equals x squared, the best graph to get on the test. Y x squared, x equals to 0. That is vertical wall over here. Y equals to 4. Y equals to 4 is horizontal wall over here. Y equals to 4. And then funny that this is the area they gave us, but also y equals 4 is the axis of rotation. So that's usually my notation like so. Then, as you can see, since there is no gap between the axis of rotation and the area, the volume of the object we receive is solid. There's nowhere to pour water in it, and it will not stay anywhere. It's completely filled in object, solid. So, what do we know? We know it's going to be dxk. Okay, we know it's a solid object, so it's going to be disk. Also, it's a dx because we're rotating about something that's parallel to x-axis. So the formula will be volume equals pi r square dx from A to B. That's it. Formula is still the same. So what does this shift even do differently? R will be different, but it's still, I would not even, okay, fine, shift. But it's nothing new, it's still area between the x. It's area between top function minus the bottom, because it's the x case, as you can see. So very good. We don't know A and B. A and B tells us where is my object from first x-axis, yeah, location on the x-axis from A to B, and to the second one. The first one is 0, the second one, I don't know, we have to figure it. It's not 4, actually, we should figure out. So let's find it. 3. How to find it? The first one is done by intersecting parabola and x equals 0. So x equals 0 definitely is the first one. But the second one is not obvious. The second one comes from intersecting parabola, y equals x squared, and y equals 4. So you see, if you're not patient or careful enough, you might assume it's 2, but it's not. It's 4 equals x squared. So x gives you 2 points, plus or minus 2. Minus 2 is this point over here, and we don't need it, so we only choose point plus 2. The integral is from 0 to 2 pi r squared dx r squared, pi r squared. Well, let's see what my r is. Find the axis of rotation. This is the axis of rotation, and shoot to the edge. Let's shoot to the edge, like so, of this yellow area I'm working with, right? This is the area. How to find this area in yellow? We're going to the previous chapter. I will do top minus the bottom. Since this is, we already chose the case. This is what we call vertical slicing, because all coins or those discs are standing vertically like this. And they all have the same width, right? But they have different radii. So how to express this all different radii? Function on the top minus function on the bottom. Function on the top is this y equals 4, which is exactly comes from the shift. So some students just memorizing it's always going to be shift involved into these calculations. And the other one is not 0. The other one is the parabola. Y equals x squared. So minus x squared. Check. There should be no y variable inside of this integral because it's the x case. So solve it, and we know how to solve it, right? It's the square of the difference. You can check it in the solutions. So sometimes we just ask you just to build the integral is good enough. How about that? What do you think about that? Before we move on to shells. So let me check chat. Nothing in the chat. Nice. Well, I don't know. Nice. Either it's like really bad or really good. Hopefully it's not bad. Shells. Shell method. So we only have a couple topics to cover left. Shell method is instead of the pi r square minus pi r square, we just do 2 pi r now. Also 2 cases, but there's 2 things to remember. Axis of rotation will be flipped or the opposite. Okay, how to write down in English the opposite? Changed. Different from, okay, different from. Actually, I have it here. Rotation is around, blah, blah, blah. So, okay. Is the opposite from the x or dy case, kind of like that. That's what I'm trying to say. Axis of rotation, if it's around x-axis or something parallel to x-axis, you will choose dy case. If it's y-axis or something parallel to axis, you will choose dx case. And that's the whole point of the shell method, because it allows us to do this trick of switching the order of the variable for integration. And the other idea is that we're imagining the onion, and instead of slicing the onion with a knife, we unfold it. We take the outside shell, cut it, and when we're unfolding it, it actually creates a rectangle. We know the width of the rectangle, the area of the rectangle, width times height, height times width, right? Unfolding the next one, and next one, and next one, and then collecting them all together gives you how 2 pi r was created in the formula. Height is simple, while width is not simple. Width was created from unfolding something spherical, circular, because it's rotation. So we're working with something circular. So this one is 2 pi r. That is the circumference of the circle, which we cut, which we had to cut like this to unfold. So you also can imagine the label of the can, soup can. That's why they like this example so much, because that is very visual. We all hold in our hands at least one, some kind of can. If you take this label, and fold it, it will be a rectangle with the circumference being your width. So the formula is 2 pi r, and then the width, as always, 2 pi r times h, and the width is always this dx or dy case from A to B. So this is the idea. Looks very simple, but what were some kind of weird ideas behind it, which students usually get stuck with? R and H are both functions. So you will have to figure out R at some point and H. If there's no shift, then R matches with the variable X or Y, because I'll show you in the example, that will be all possible variations of the radius. It's just exactly located on the X or Y axis. So it's exactly the same function. While H, height, is area between graphs. H is area between graphs. That takes us to the previous chapter again. Let's do the example. The more examples you do, the better it is. Basically, I just like choosing some examples close to the review, and then it's A, it is fair, and B, people just do well, so I feel good about it. For example, 27, number 27, which is also number 13, I think. 14. Example number 14. X and Y, X times Y equals 1. And then X equals to 0, Y equals to 3, and then about X axis, like so. Step 1, do 2D picture. Somehow 3D picture messes people up, so I usually don't recommend to do a 3D picture. I recommend to imagine it, but don't draw it, because the limits of integrations are coming from 2D picture. So let's do it. X times Y equals 1. It's the same thing as Y equals 1 over X, kind of, right? So that is this kind of function, like so. But we don't need both parts. We only need one part. So let's erase this one. Sometimes people say only in first quadrant and stuff like that. X equals to 0 is this. That does not make any restriction for you to know. Y equals to 3 is the wall. Also, one is missing then. Oh, y equals 1. I did not see it. And y equals 1 also, comma. And then there are two horizontal walls which make the restriction of this graph. This one and this one. Y equals 1, y equals 3. And that creates a nice area. Like so. This area was rotated about x-axis. Looks like this. This is my x-axis. And I don't create a 3D picture. 2D picture is enough, but I do imagine like, okay, there's some kind of 3D object. Again, we don't care if it's hollow or shallow anymore. And that is why I don't need a 3D picture. 3D picture was required for the previous chapter. Here, it's a shell method. We chose it to use a shell method. Oh, let me explain you why it's a shell method. Step 2. So, since it's rotated about x-axis, you expect to do the x for the previous chapter. And actually you could do it here, but it will be, then you will have to write down y equals 1 over x, these kind of things, find points for x, but we already given points for y, which is kind of convenient. And this would be nice to have dy case here. To have dy case, you use shell method, or we just tell you use shell method. But actually this particular example, I can see you can do both. The thing is, it's a shell method or it's a washer, because if you want to choose not a shell method, it will have a gap. So it is dy case for shell, because it's always the opposite variable if you choose to have a shell method, or if we ask you to do that. So let me cross this off. For now, let's see what's happening. Since it's a shell method, the integral will look like this integral. So shell dy case from c to d 2 pi r h dy. At least remember this formula. So right now, just out of nowhere, just remember the formula from my brain just show up. So that's a good thing. Something stays like this. I remember it's a circumference times the height. Okay, not too bad. Now you need to find C and D. And the thing is, many students, when they draw the 3D picture, they think that C and D will come from the 3D picture. And that's what the mistake is about. And I noticed that. So I now recommend don't draw the 3D picture. They're asking about this piece, C and D. What is the height of this 2D piece? 1 and 3. We don't even have to find it because they are there. 2 pi is 2 pi. Now we just need to figure out those two functions. Since there is no shift, this will be y. This is my radius. Y. Let's see. What is the radius of this 3D object? The axis of rotation is x-axis. What is the radius over here? Oh, this radius is 3 minus 0. Which is 3. What is the radius over here? Oh, this radius is this point minus 0, which is still this point. So it will be also y. Y equals. What is the radius over here? Oh, this radius is 1 minus 0, which is, so technically speaking, you can just see it's just different y's. The height of the 3D object matches with the length of the radius. And that's why we can just claim it as a function of what x equals y. This is just y. The height matches with the variable y and with the radius. With the x-axis, the x case, it will be x. So I just wrote down y like so. Height, though, of this object will be the area between graphs. And since it is the y case, it will be right minus left. Right minus left, like so. Let's see how it works. What is on the right and what is on the left? What is the area of this from the perspective of dy case? On the right, we are working with y equals 1 over x. But we're not supposed to write it this way. Oh, actually, let me write it down originally. That's even better. X times y equals 1. That's the function on the right. What is the function on the left? X equals 0. That's what we're going to have here. X equals 0 is on the left. And x equals what? 1 over y is on the right. No squares needed. It's 2 pi r times h. 2 pi r is the circumference, h is the height of each sliced onion, dy, make sure there's no x variables in the integral. So the simplified version will be, I usually kick out 2 pi outside from 1 to 3 y times 1 over y dy. So that actually is integral of 1. What is the integral of 1? It's the length of this interval of integration. It's going to be 2 pi, 3 minus 1, which is 2 times 2, that's 4. 4 pi. It's better be positive because it's volume, units cubed. Shell method in this example is faster. And in many other cases, it is faster. And that's why students like it so much. Check the shift by yourself in my solutions, how the shift works. Because I want to move on. What do you think about that? What? Let me review the quick problems, which are arc links. That is fast, but also just a couple of things I wanted to say. Arc links can be hidden as a chapter like so. It will be on test, definitely. Usually students do really well, so I like to put it on the final exam as well because of that. Arc lengths or lengths of the curve lengths. So I was teaching, remember the snake, right? Like how would you measure the lengths of the snake? Like so. So length of the snake is still the integral, still the idea that you kind of measure the snake with tiny segments. The smaller, the better. Accumulate them in the integral from A to B. That's it. And there's a formula. So the formula we need to remember is A to B or C to D. A huge square root 1 plus derivative of the function squared dx, where the function is the snake, y equals f of x. Yeah. Now, don't forget to differentiate. If you don't differentiate it, you will mess up. What else? We did in the review, you will see a kite or a drone flying. Find the length of the rope. Blah blah blah. That's the same thing. So the same formula. Just it's nice to put some kind of applicational problem. Engineering department asked us to do that. Snake, drone, or a kite. Kite, I think with y here. Kite. Same thing. Flying kite. What is the length of the rope if the function is given? And you just use the formula like so. Number 20, 15. Example number 15. So y equals 1 plus 6x to the 3 halves. X is from 0 to 5. Well, listen, if you have x given from 0 to 5, then the integral will be dx. If you have y equals from 1 to 9, the integral will be dy. So that totally gives away the whole situation here. So it's going to be dx case, and everything is given. Your job is not to mess up. The length of this arc is, so for example, this is drone, flying, blah, blah, blah. It will be integral from 0 to 5, nothing new here, a huge square root, 1 plus derivative squared dx. And your job is just to figure out the derivative. Y prime is 0 plus 6 times 3 halves x raised to the 1 half. And the thing is, if you don't take derivative, it will be very hard to integrate this. So it will be, simplify, 3 times 3, 9. 9 x to the 1 half. And now you can integrate that easier than before. That's it. So either you have to choose this formula from the offered list of functions, or you actually have to finish integration. Both are important. So that was easy to review. Work problems, let's do series and sequences because it's new. And then at the end, I'll review a bit work problems for you. Series and sequences, let me check. Okay. Series and sequences. What kind of questions they can be? To be honest, it will be on my recording. Be careful with that. To be honest, I just take random problems from the practice exam, which is this review PDF file I'm looking at it right now, which I gave you guys in the modules. I never create anything new. I just take it from there. And for example, check this. So it's not 16, right? Look at this number 28. Number 28 has a sub n equals 3n plus 1 over 3n minus 1. So for the exam, I just do like 5n plus 1, 5n minus 1. Sometimes I do 7n plus 1, sometimes 11n plus 1, 11n minus 1, or 2. That's it. Like I usually for this second exam, we don't want to put anything hard for the sequence series chapter. So if you can do these, I promise you, you'll be fine. There's nothing going on there, nothing extra weird. So let's see. They gave you this. And now there are two types of questions. Two types of questions on the same a sub n. Question, that is important. Question number one. I would do question number one, Q1. Check if the sequence, and I put it in bold for you on the exam, sequence a sub n, so in braces, converges, question mark. And if it converges to what? With sequence, you check the limit. That's it. That's it. You just remember for sequence, check the limit. The limit n goes to infinity of, and you just plug whatever we give you. In this case, it is 3n plus 1 over 3n minus 1. That takes you back to the limit chapter. Remember how to do limits with polynomials. Find the leader of the top. That's how I teach it. 3n is the leader of the top. Find the leader of the bottom. 3n is the leader of the bottom of the fraction. Compare them. So it's actually a limit as n goes to infinity of 3n over 3n. If a variable, which is n in this case, have the same powers, then the answer will be the ratio of the leading coefficient, 3 over 3. And usually my students in calculus 1, they just circle like this. 3 over 3 is the answer, which is 1. That is the convergence of a sequence. The visualization will be like so. Sequence is the data. Sequence is the data set of points. What points? At 0, when you plug n equals 0, it will be 1 over minus 1. Which is kind of a weird example, but okay. Anyway, I'll just randomly just do. So points, and you just look at those points, and a data scientist asks you, do you see any pattern? Where does it all go? And you kind of connect the dots. It creates a function. And you check the limit of this function. What function? The function 3n plus 1 over 3n minus 1. That's this function you created. And this function has happened to have a horizontal asymptote. This function from calculus 1 has a horizontal asymptote called y equals 1, because you know limits, 3 over 3. So that's 3 over 3 equals 1. And I'm like, oh yeah, I can see the data set or those points do go to 1. While series is not like that. Series are more serious, more complicated. Question 2. Series. That is called a sum of a sub n. N is from 1 to infinity. You see the notation is different. That will be as well, okay. Converges. And if converges, then 2 what? And that is not the same thing. Go ahead. Now we're talking about a sum. Put the function we gave you, which is 3n plus 1 over 3n minus 1 into the sum notation. N is from 1 to infinity. And check if this guy converges or diverges. And it's not the same thing because for the series, we're not checking the pattern of the points. We're not connecting the dots to see the pattern. Dots visually I can see stacks around height 1. For series, we're checking the height and adding them up together. Height of each point added up together infinitely many. That is the sum. So yeah, that's complicated because sums might end up to be infinity or might end up to be a finite number. And then you guys learned last week a divergence test. That's the only test we're going to test you in the exam 2. And then for the exam 2, we're going to learn exam 3, we're going to learn more tests on Thursday actually. Divergence test. This is a divergence test. Divergence test has a cool explanation in my culture. So Russian Ukrainian education actually has this idea. I usually explain it using hedgehog. It's a cute explanation. When you hold in your hands, okay, let me actually show you this on camera. That's kind of cute. Students like it. They thought. Okay. Go. So this is a nice recording with the camera. When you hold an object in your hands with closed eyes, and we tell you this is an animal, without looking at it, can you guess what animal it is? And you're touching it. So, and we gave you a hedgehog, and you're touching it. And you can feel it's pointy. So there are 2 ways to see the situation. We first told you you're holding a hedgehog. You don't believe me. You're touching it, and you expect it to be pointy. That is what it means to have a limit of the series to be 0. We expect it to be 0 in order to have convergence. So divergence test can only tell you when it's not a hedgehog, but it cannot tell you if it's only a hedgehog. So that definitely makes it more confusing. Let me say it this way. You're touching the animal and it's bold. That's what I'm trying to say. The divergence question, the divergence test tells you, check the limit. The limit better be 0 for the series to converge. If it's not 0, it does not converge. That's it. So you're touching this animal in your hands and you don't see what it is. And it's bold. Maybe it's soft and fluffy, but it doesn't have needles. Since it's not pointy, you definitely can say, I don't know what it is, but it is not a hedgehog. That is the idea. So I usually draw a cute picture of the hedgehog. And it's like so, right? And then, you know, it has needles. It has to have needles in order to be a hedgehog. So the divergence test says limit of the terms has to be 0 in, okay, let's do it like this. If it's not 0, then it's not a hedgehog, unless of course you have, we don't accept cases when the hedgehog is sick and doesn't have its ball. Then series diverges, like so. So it goes only one way. That's what's called divergence test, not convergence test. It only goes one way. If the limit is not 0, game over. The series blows up. The visualization is the points went somewhere like so. Well, when you start adding up all those heights, then definitely they will not converge anymore because there are too many heights to add. The limit of these points did not go to 0. The limit did not go to 0. But if limit is 0, that doesn't give us any information. No in 4. It still might diverge or converge. And that is the confusing part, because when you hold the hedgehog and you touch and you feel the pointy needles, it might not be necessarily a hedgehog. That is the idea here. What can else it be? Any other animal that has pointy needles. For example, what do you think are other examples of the animal with needles? Porcupine, exactly. What else? Any other creative examples? Porcupine is a nice one. Anything else you know that has needles? Yes, echidna. Echidna is a really cool one. And then the popular one I like, a student will usually mention if they like marine animals. Which one is that? What do you think? Sea urchin, right? So someone asked, are the test questions still the same or review or derived from the review? I mean, I can't tell me they're exactly the same, but they're very close to the review. That's why you also do the review. Yes, or even this fish that looks like a ball with needles. Remember that one? That one also can be the object you're holding in your hands. So this test works only one way. Pufferfish, yes, exactly. Only one way. If there's no needles, definitely it's not a hedgehog. At least we know that. So if limit is not 0, then definitely the series diverges. But if there are needles and there's no info, because it might be something else. How to apply it in this situation? We take the same limit, and we check it exactly the same way we did before for the sequence, and we get the same answer, which is 3/3, which is 1. But the answer will be the opposite for the final answer. This is not 0. That means points, like I already showed before, did like so, they stuck around 1. But what will be the sum of heights if heights stuck around 1 all the time? 1 plus 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 1 infinitely many times gives you infinity. The area becomes infinite. And series asks for the area here, the height, the area. So there will be connection with integral soon. Area below the graph and stuff like that. Answer diverges. Answer diverges by the divergence tests. We're gonna have more tests soon. Divergence test. And now check out other examples. I have all the examples in my review side by side, so you can check these out, including geometric series and sequences. You need to know these too. For example, let's do one more, and it'll be satisfying to do one more. 17. Number 17. No, let's do it. It's 33, but it's 17 right now. A sub n is 5n plus 2. People ask about this in forum and I answered. I have YouTube video on this. I have YouTube videos on many of these actually things. Over 6 over n plus 2. So what is the a sub n? You can actually rewrite it like so, 5, 6 to the n plus 2 using properties of powers or exponents. So question 1, sequence in bold, sequence or data set of points, converges, diverges. Well, let's check the limit. The limit of 5 over 6 to the n plus 2 as n goes to infinity gives you what? Several ways to see it, but that's a geometric sequence actually. Sequence. It's a known geometric sequence. Geometric sequence is r to the n type of sequence. And it converges when r is less than 1 by absolute value. Sequence though. That is called geometric sequence. Definitely check either my videos or the book or the class notes about that. like so, r to the n. So your r is that a repetitive term, 5 over 6 plus 5 over 6, 5 over 6, 5 over 6, but every time it's raised to a new power. That is my r. To be honest, if you check it in your calculator, you will see what the limit is. Just check 5 over 6, even if you don't remember geometric sequence, to like what, 10,000. That's a number sense for you. Check that. That's a very small number, because every time you're raising a fraction which is less than 1 to a new power, and then definitely it converges. Converges to what? It becomes smaller and smaller and smaller and smaller, so it converges to 0. Sequence converges to 0. Did I say it last time? Last time I better did. Oh, see, I never answered the 10. Okay, yeah, this one. So the sequence converges to 1. That is the answer for the part 1 for the previous question. But for the second part of that question, I said answer diverges by the divergence test. How about here? Answer 1 is converges to 0. Nice. Second question. How about series? Remember, series is a sum, so it behaves differently. Series of a sub n. So series sum of 5 over 6 n plus 2 will converge by the geometric series. N is from 1 to infinity. We know this from the notes that geometric series converges if r is less than 1, though, by absolute value, not equals to 1 anymore. It has to be strictly less than 1. And then it converges. So it converges to a known number called a sum S. Capital S means sum. A, that's the first term, 1 minus r. A is the first term, like so. And r is that 5 over 6 here. So that means answer converges as geometric series, GS. That's a very common notation, geometric series to the finite sum. So it shrinks so fast that it will be the first term over, let me do the easy part, 1 minus r. 5 over 6, that is 1 minus r. But what is the first term? The first term you need to plug n equals 1, since we're starting counting with 1. N equals 1 gives you 5 over 6 raised to the 1 plus 2. If you simplify this, it will be 5 6 cube, 5 6 cube over 1 6, right? 6 over 6 minus 5 over 6. That is 125 over 36. Done. Nice. So this is important. And to be honest, yeah, I just copy paste problems like this with different numbers. So instead of 5 6, maybe it's going to be 7 8, or maybe it will be 6 5. You should know the difference. If r is greater than 1, then it blows up in both cases. Just diverges. That's it. You see this if part? Converges, geometric sequence converges when or if. So if that doesn't help works, then it blows up. Otherwise, diverges. So if the, I actually can write it down. Note. Diverges if we had example of 6 over 5. Yeah. Then it's greater than 1. It will be what? 6 5. 6 5 definitely blows up. And then sums of all of this also blows up to the n. Oops, sorry. To the n plus 2. Good. That's all you need to know for now about sequence and series. And that's why there's so few problems on the review, because we don't really plan to put anything more yet. That goes to the third exam. So what is left to do? Do you know? Your favorite topic is left to do. Who knows? What is the one last topic we did not review yet? People like, I'm done. Right, work problems left. So usually I don't like putting anything complicated on a test for the work problem. I recommend you to review 2 things for Tuesday, work problems. And one is, what? Find the work done moving the particle from one place to another place. Remember that one? So I'll break it down. There were several of work problems. Now for the exam, just review these 2. Find the work done moving the something, the stool, the chair, chair is a stool, container, the particle from A to B. Review that and review pool problems. And I don't usually put anything complicated on that chapter, problems. And I gave you in the modules, if you go to modules, several nice explanations done. I just asked someone to give explanations, and like maybe someone have better explanation than my explanations, and they gave me very nice explanations for number 43, 44, 41, 42. Very nice step-by-step solutions are given actually over there. And I'm like, okay, I will just post it for students. They look scary a little bit, but your job is not to freak out and build the correct integral. Or build it and choose it from the list, for example, right? If it's multiple choice. So for example, I would check my notes, the notes we did. Notes, and then review. And I usually just take one of the integrals from there. Very convenient. There's nothing, no complicated shapes, no related triangles, similar triangles. That's too time consuming. So just need to know what is your A and B, and what is that function that goes inside of the integral. So let me see. I think this one was good. So check the practice test. I think I even gave you solutions there or something like that. 42. The complicated part of those problems that it is creative, which is like not always works well. The creativity part. Now, the problems do rely on where and how do you put x-axis and y-axis. The shape matters as well. So I usually on my test give some typical shapes, right? Which is a circle or a cylinder or like a quadrant one. So those are easy ones. But you should remember pi r square will be used for the sphere, for example, and so on. And you also remember that the integral will involve. So what was the formula with it in our notes? The integral involves gravitational g, constant. What was the name of that constant? I immediately forgot. Rho. Oh, remember, that is the constant of the liquid. Well, this is weight. So if we give you weight, you actually don't have to have these two. Then the slice of each shapes of water that we need to lift comes into the picture. So it starts here, which is that is your slice, right? And the slice will depend on the picture. And then it's that's usually dy case because we usually do some pools, which will look like this. And now it depends if it has a fountain or not also. So area times the slice itself. What the function actually does not really match all the notations. I should match my own notes, which I forgot. Who can check what my notes look like? They were changing it recently, so now I don't remember anymore. Notes, series and sequences, work. Module 7. Module 7 has work problems. Yeah, I just check here. See, all the files are posted, which is very convenient, both for me and for you. The spring ones, let's not do spring one on the test. Although I like them personally, but usually we don't put them on the exam. But we do put the other two, pool, D. This one was D. So, for example, and just basically, let me give you the example why I'm talking so much. Find the work needed to pump all the water out of the cylindrical. What is my sin? That's how I wrote cylindrical. That's funny. Cylindrical. That is hilarious. What kind of what is this? Funny. Anyway, it is cylindrical shaped tank. Height 10. It looks like this. Cylinder looks like so. And now we see it matters how you put it. You can put it below the earth. You can put it above the earth. Maybe it's a pool, then it's below x-axis. You can put it as a tank standing on the floor, then it's above x-axis. The answer will be the same. You just need to figure out the limits of integration correctly. The height of the tank is given as 10 meters above the ground or whatever. It's just the height, whatever it is, above or below. The water have to be pumped with a fountain. The fountain has 15 meters. No, the water is pumped 15 meters total above the bottom of the tank. So the extra piece is 5 meters. That's the fountain, right? The shape is given and the radius is given 5. So how the integral will look like? Work is done to lift all of those slices of water. So also it can be not water, maybe it's chocolate or anything else. But in this case, it is water. All the slices have to be lifted. So the bottom one will be the heaviest one because it takes so much time to lift up. The one at the top will be the lightest one because it's already on the top, and so on. Rho is 1000 for the water. That is water constant. 9.8 is the gravity on Earth. That gives you weight. So actually it's just one thing. 2 functions will be here. Let's see how to build those. dy, because we are moving something up, and because each slice has a width on the y-axis, like so. That is dy. So it's case 1. It's always case, unless you want to do it horizontal. You can actually. The answer also will be the same if you make it properly. Anyways, the water is traveling. Y variable describes the physical. Let's see. Not to confuse you here. Oh, the fullness of the pool matrix. That's what I wanted to just say. Yeah. Where should I put it? I should put it here. For the water problems, not only formula matrix, but it's A and B. B should be water in the tank, I guess. And now you understand it's not always full. Yeah, that's important. It's not always full. So it will be from 0 to 10 because in this case, it is full for this particular problem. And this problem has a name. I should probably just point out the name of the problem. The number is, oh, it doesn't have a number, but it's page 3. That is page 3 notes. From A to B. So it's from 0 to 10 because the water is full. If it's only 8 meters, it will be from 0 to 8. Y represents water, so don't make Y anything else. It's not the shape of the tank, actually. It's how much water we had originally to lift. Then RA in this case will be pi r squared because it's a circle. But again, it might be not a circle, maybe it's a square or triangle, which you had in your formula. R is given as 5, so it's going to be 25 pi times 25, or 5 squared. Finally, what is the water lifted variable? Water lifted. Lifted. 15 is the highest level. That's top minus the bottom, right? Minus, and the lowest level is keep changing. That's a shift. This is your shift here. The bottom is keep changing. It starts from 0 when y is 0 and ends up to be 10 last variable. So 15 minus 10. And that gives you that fountain 5 meters. So if you can build this, it's easy to integrate, and B, just choose it from the list. Let's check it. Kind of that's all. 2 hours, exactly. That's what I thought. So those two things. And then what about the work done by? We just gave you this formula. Let me finish my notes nicely. I think it was here. Integral f dx, right? Remember, so it's a force, force times distance thing for this part. Joules is force times distance, like so. So that will be important. And basically check the problems of find the work done by moving the particle from A to B from the review and from the notes, I guess, also good. And the pool problem, that's actually good enough. So very typical shape. Don't check any awkward shapes, no similar triangles and stuff. And you will be ready. Oh, I think this is good enough. Any questions? Thank you. People said thank you.